Your next set of notes are going to be on naming ionic type 2. So the idea of ionic type 2 is that these are multiple charge metals. So multiple charge metals mean that they come in various charges. So there's iron with a 2 plus charge or iron with a 3 plus charge. So they come in multiple charge types. So metals that are considered type 2 are basically all of these metals in what we call the D block, which is this dip right here. Except for not zinc and silver. All of these metals underneath the staircase as well. And then the F block, these metals down here. So these are all considered type 2 metals, meaning that they can have various charges. So the rules for these, when we go from formula to name, are going to be different than our type 1. We're still not going to use any prefixes, but we are going to start using Roman numerals. So let me erase some of this stuff that's already written down here. And let's talk about going from formula to name. So the first thing you're going to do is you're going to write the name of the first element. So we always write our cation first. And then what we're going to have to do is determine what the charge must be. And we're going to write it as a Roman numeral in parentheses after that cation. And then the next thing we're going to do is write the name of the second element with the suffix "ide." So we always write our anion second. So actually what I like to do is I like to write the two names first. So if I'm looking at this one, I already know it's going to be copper and chloride. So I'm going to write copper, and then there is going to be a Roman numeral in here, and then it's going to be chloride. Now, the question is, what is the charge on this copper? Because copper comes in various charges. So what I'm going to have to do is I'm going to have to look at my anion. So I see that I have 2 chlorides. So I know that every 1 chloride has a minus charge, and I have 2 of them. So I have a total of a 2 minus charge over here. Well, I also know that my copper chloride has to have a net charge of 0. So the charge on my copper, if I only have 1 of them, has to be a 2 plus in order to cancel out the charges on the chlorides. So this is going to be copper 2 chloride. All right, so let's do it again. Let's look over here at this one. I'm pretty sure I just made it up, but we've got a copper oxide. So this is going to be copper something charge oxide. Now, in this case, I have 3 oxygens, and I know that each oxygen has a 2 minus charge. So that means that there's a total of 6 minus charge in this whole thing. And I need it to be net neutral. And I've got 2 coppers, and I need those to add up to a 6 plus charge. That way these cancel and I get a net neutral. So the charge on each of these coppers must be a 3 plus to add up to 6 plus. So this is copper 3 oxide. I do like to sometimes write out my work like this. I do find it very helpful to see it. So now rules from going name to formula. In this case, it's a little bit easier because in the name, it's going to tell you the charge. So I'm going to erase some of this from before. And we're going to start by writing the element symbol. So we write the symbol for the cation and the symbol for the anion. So iron is Fe, oxide is O. Now the trick is, based on their charges, how many of each do you need to create a net neutral compound? So iron here, I'm telling you with the 3, is a 3 plus charge. That's what we did above, right? Is we figured out what the charges must be on the metal, and that's what's written in the Roman numeral. So when you're given a Roman numeral, that's its charge. Oxide is in family 6A, so those have a charge of 2 minus. Now, if I'm working with my whole net neutral idea, I know that if oxygen has a 2 minus charge, and iron has a 3 plus charge, that these two are not canceling each other out. So I'll need another oxygen to cancel the charge on that iron. But again, now this isn't canceled out. So I'll need another iron. And then I'll need another oxygen. And basically you're trying to get to your lowest common denominator. So I'll need 3 oxygen to get to a 6- charge. I need 2 iron to get to a 6+ charge. And now I'm at a net neutral charge. So that required, again, I needed 2 of my irons. And I needed 3 oxygen in order to make it neutral. Again, you can use a swap trick. It will still work here. So you can get Fe3+, and you can swap just the number into the subscript. Again, this is a trick. And you can swap the 2 over, and then you'll get the same chemical formula. Remember, if you're doing any swapping, you do have to reduce to your lowest whole number ratio. And I said I would show you another example. So if you're looking at tin oxide here, then we'll see that in this particular case, I got a 2 and a 4 as my ratio when I swapped them. And so that needs to be reduced to a 1 and a 2. And again, you don't have to write 1, that's assumed. So in this case, I think this was tin 4 oxide. So tin with a 4+ charge. Oxygen has a 2- charge. And so if you do the swapping trick, if you swap the 2 and the 4, you get SN2O4, but you do have to reduce that. Because if you're looking at just the net neutral rules, right, if tin has a 4+ charge and oxygen has a 2- charge, you only need 2 oxygen to cancel out that 4+. So the actual formula is 1 tin and 2 oxygen. All right, so you are going to practice now going from name or formula to name and then name to formula.